Okay, let's continue our discussion on annuities. So from the previous video, what we worked on is finding the annuity when the interest is compounded annually. And when you have compound interest, sometimes you don't just compound one time a year, okay? So just like when we worked on compound interest, sometimes you can do your payments more frequently within the year, okay? And you can see that our N is the number of times it was compounded within the year. So I know it's a lot crazier formula, but as we have learned from the previous chapter and from the previous video, as long as you're using your calculators properly and you know which values to replace in here, then you should be good with your maths. All right. So let's have this example. At the age of 25, to save for retirement, you decide to deposit, okay, $200, this is our P, into an IRA at the end of each month, okay, with an interest rate of 7.5% compounded monthly, as we can see here. How much will you have in the from the IRA when you retire at the age of 65? Now, one thing that is very tricky about this is that some kids will automatically, oh, the time is 65. No, it's not, okay? You have to remember, when did you start saving? You started saving at 25. You wanted the money when you are 65. So how long do you make those deposits? Well, 65 minus 25 is going to be equal to 40 years, okay? So that is the T that we will be using. All right, so using our formula, A is equal to P, let's use the giant parentheses, okay? 1 plus R over N, so our R is 0.07, oops, sorry, my bad. Let's not use our values yet. Let's just go over the formula first, okay? R over N raised to NT, okay? And then you have minus 1 at the end here, okay? All over R over N. That is our formula, okay? So let's replace our values. Our P is you are just depositing $200 every month. Is that very heavy? Not that much if it is a monthly payment. All right. So we have 1 plus our R, 0.075 over N, which is 12. Okay. We have 12 as our N, and our T is 40 years. All right. Then we have a minus 1 at the end here. All over, okay, another fraction, 0.075 over 12. So that type this in your calculator as it is, and you will see that the annuity at the end of how many years? 40 years. You are possibly looking at $765. Okay, so it's almost like more than $500,000 just by saving $200 every month for 40 years, okay? Now, this is the interesting part, okay? Remember, the interest is the annuity minus total deposits, okay? So the annuity is $604,765 minus. You were depositing $200 every month. So how many times in a year? 12 times in a year. For how long? For 40 years. Okay? So you were depositing a total, all in all, your deposit was, so all in all for your deposit, you have, this is 200 times 12 times 40, you'll get a total, you were able to deposit $96,000. So almost $100,000 deposit over the 40 years. And if you will see, the difference of this is $508,000 765. So this is the interest earned over 40 years. How much did you pay out of pocket? How much did you deposit? Almost 100,000 for 40 years. But you earned $500,000, more than $500,000 after the 40 years when you put your deposit for retirement into an IRA. So that is a really good amount of money. You can live comfortably when you do your retirement with this amount of money at the end of 40 years. All right? Okay, so of course, when we have the future value, we also take a look at if you have some financial plans, like you are targeting this amount of money that you will have by the end of this number of years. So how will you determine the deposit? Okay, so this is our formula. So P is the deposit that needs to be made. Now remember, if it is compounded annually, okay, compounded annually, you just need to remove the N in all of this formula. If it is compounded several times, then you will have to include the N. Okay, so one thing that you would remember and you will notice is that the payments are being made monthly. Typically, that's how it is. Like you make a payment for your house, for your car, things like that. So you will notice that most of our word problems will be compounded monthly, or the deposits are made every month. Okay. So let's take a look. Let's say that you would like to have $20,000. So this is your future value to use as down payment for a home in 5 years. This is our T. By making regular end of the month deposit, so you can see monthly deposits, annuity that pays 6% compounded monthly. So how much should you deposit each month? So looking at our formula, okay, remember the formula is P is equal to A times R over N divided by, okay, parentheses, 1 plus R over N raised to NT minus 1 bigger parentheses. That's how it would look like, okay? So if we plug in the values, the future value is $20,000, and we multiply that by 0.06 over 12, that's R over N, all over 1 plus R over N raised to N times the T, which is actually 5 years. Then we have that minus 1 at the end, bigger parentheses, okay? So putting this into your calculator, the approximate value, if we're gonna round it up to the nearest whole number, there should be a monthly deposit of $287 for 5 years so that you can get that annuity, okay? Now, for letter B, of that $20,000, how much comes from deposit? How much are the deposit? And how much is the interest? Okay? So, the deposits, how much are you making deposit? You are depositing $287 for 12 months. For how long? For 5 years. Okay? So, your total deposit is $287 times 12 times 5. So all in all, your deposit was $17,220. Okay? Now the interest, now remember, the interest is going to be the annuity minus the total deposits. And in this case, our annuity is $20,000 minus your total deposits of $17,220. So the interest earned on this amount is $2,780. So that's small interest earned for 5 years when you are making a deposit of almost $300. Okay? So that is how it would be worked on when you are looking for, when you have a financial goal and you want to plan on achieving that goal, then you will have to find out how much deposit you are going to make, how frequently you are going to make those deposits so that you can achieve that financial goal that you have. All right.